Good morning, everyone. Holy cow, look at this room. Florida has arrived. This summit is all about teamwork. This was in the best tradition of partnership and teamwork, collaboration and synergy between DOT, THEA, FAVS, and Qatar. I'm really delighted. We have a lot to do in this panel, so I'm going to get started right away. Our first speaker, he really truly needs no introduction. He's the project manager for Google Cars. Google Cars are my hero. It's why we're here. So I really appreciate them coming out from the West Coast, and I'd like to introduce Anthony Levandowski.
Thank you so much for coming here this morning. It's a pleasure to be here, and I want to give a special thank you to Jeff Brandis, the representative from one of the nearby districts, who, without his leadership, I don't think Florida would play such a big role in the advancement of autonomous vehicles that it does today. So thank you so much. Are you guys going to be able to switch to perfect? So some of this stuff is new. Some of this stuff is used and have been shown before, and so I encourage your questions after the chat here, because I really want to start a dialogue, because we think this is going to be a partnership together in order to be able to deploy these technologies into the markets, and we're very excited about Florida. Everybody's always asking why does Google care about this? So it's kind of an obligatory statement, because we're not a car manufacturer, we don't have factories, we don't make other technologies that are built into the car, but we do make a lot of technologies that are used in the car every day. Some safely, some potentially not as much. And Google, at heart, is a technology company. The engineers love to build things. We're an engineering-driven company, and wherever we see solutions that can have a huge impact on humanity, and there's a really technical challenge to be solved, is where we excel the most, and that's what the problems we love to work at. So how do we think about this problem? We think of autonomous vehicles as an opportunity to kind of reinvent how the car is made today. And what would the car be like today if there was 100 years of computer engineering before the first car was ever made? It would be very different, obviously. This is a plot that many of you guys have seen. Effectively, this is showing that the price of computational power is falling dramatically. It's falling exponentially. Not only is it exponential, but it's an accelerating exponential, meaning that in 10 years, the available computing power will be somewhere about 30 to 40 times what it is today for the same amount of price, which is a pretty shocking thing to think about. There's no other industries that have this amount of growth and acceleration to the power that you can get for the same amount of money spent. So what this basically says is that it doesn't matter that the computer was invented after the car. In 10 years or so, it will almost have been as if there was 100 years of continuous improvements that happened before. So it's not a new idea. Obviously, you guys saw a wonderful Disney's Magic Highway video showing here. I'll show you a little bit of something we did in 2012, which we think speaks a little bit to our aspirations for the technology. Given that we're not an automotive player, what we don't care about is improving the existing products a little bit. We have great companies doing wonderful work there. GM's coming up next, Volvo, Ford, Daimler, Nissan. Everybody's doing a great job at making their products better. We want to reimagine what it would be like to have technology really take a bigger part in people's role in transportation. So here's a quick video.
No hands anywhere. No hands, no feet. No hands, no feet. No nothing. I love it. So we're here at the stop sign. Yep. Car's using the radars and laser to check and make sure there's nothing coming either way. I find myself looking. Old habits die hard, man. They don't die. Hey, anybody up for a taco? Yeah. What do you want to do today, Steve? I'm all for tacos though myself. All right, well, let's go get a taco at the drive-thru. And we're turning into the parking lot. How neat. There we go. Now we kind of creep along here. Does anybody have any money? I've got money. No, I've got my wallet right here. You roll down your window and order a burrito. Yeah, push that up. I'm doing very well. How are you today? This is some of the best driving I've ever done.
95% of my vision is gone. I'm well past legally blind. You lose your timing in life, everything takes you much longer. There are some places that you cannot go, there are some things that you really cannot do. Where this would change my life is to give me the independence and the flexibility to go the places I both want to go and need to go when I need to do those things.
All right, thank you. So aside from helping Steve get a taco, the technology is fundamentally important to how we live our lives today. From getting from home to work, from getting from home to going to see the grandkids, going to a movie theater, transportation is a fundamental aspect of how we live our lives. The biggest door in our house is for our car, right? So this is a pretty fundamental way of thinking about it. We're not here to take driving away from anybody. We really want to enable people to have a better driving experience. In my perspective, it's a bug in vehicles today that you have to drive them all the time. There's plenty of times when we don't want to do that, when we're stuck in traffic, when we're driving, looking around for parking spaces. These are areas where technology can play a role and really help address these kind of pain points for that. On the other side, it's really helpful for people like Steve that without this technology need to rely on other people, need to rely on other modes of transportation, and for them, this technology can take a trip that would take them normally 30 minutes, 2.5 hours. So imagine getting 2 hours of your day back every day. That'd be a pretty fundamental game changer for you. So we want to set a little bit of realistic expectations. We understand the technology will deploy incrementally. It may be different in an incremental step than you imagine. It may be gradually in focused areas, but high concentration, meaning vehicles that can be called on your phone and arrive to you driverlessly. The technology is also not going to be 100% effective. This is one of the big things that everybody's always expecting, hey, won't the technology be perfect? It's a robot. It's never going to make a mistake. I'm here to tell you, unfortunately, that's not the case. There will continue to be crashes. But what's great about this is today, whenever somebody learns a new driving skill, we all learn it one at a time, and there's no way for us to share it. Think of it as like you can have the cumulative driving experience from all the people in this room. We'd be the safest driver in the world. Well, the technology leads itself to be able to do something like that. How did we get there? We think that getting public buy-in is really important, because public buy-in is how we're going to prevent people from being scared about these vehicles. So this is back in 1997. Everybody was all excited about this. Proving that automated highways works. This is almost 20 years ago. Bunch of folks at UC Berkeley and Carnegie Mellon had 8 vehicles driving in a row, and that was fantastic. But getting public buy-in is important, but we can't wait for infrastructure changes. Whether the infrastructure is magnets in the roads here, or a virtual infrastructure, meaning we're waiting for vehicle-to-vehicle communications. Right now we don't rely on any vehicle-to-vehicle communications. We don't need any vehicle-to-vehicle communications. If they existed, it might be useful, but I would think that we might want to do it in a different way. Think of it as, all the curves I've seen for vehicle-to-vehicle adoptions are that the soonest we'd have half the fleet operational is something like 10 or 15 years from now. What are you going to do with a half operational fleet? But however, think of it, there are, today there will be 2.8 million new smartphones sold in the world. Right? That's 100 times the new vehicles market. So this is a much better way to introduce the technology, is maybe from phone to phone, an application or something else that's being built on top of an existing infrastructure that's growing much faster. The other thing to look at is there's been a lot of concepts, and we want to build something that people want to use. So this is kind of a chicken and egg. I love Volvo, but this is something I don't understand why they're doing this. Is to me, the technology is about giving you more freedom, giving you a better drive to work, and to think of it as you want to be tailgating a truck on your way to work when there's an open lane next to you doesn't make sense to me. It also doesn't make sense to me that a truck driver would get this technology installed on their vehicle, or that you would get this technology installed on your vehicle before there's a critical mass available for it. So we've taken the approach of making the problem a little bit harder for ourselves, meaning we need to drive on our own by ourselves without any modifications to the environment. So we found a way to make an expensive car even more expensive by a factor of 2. We've added a bunch of sensors. It's unrealistic the way it is today, but what we're trying to do is prove that the technology can work and can get to the place where we need to. We've built an extensive training pipeline. There's 13 levels of our driver training, because as we're driving these vehicles in public roads, we understand that we can't roll out beta software that just kind of, let's see how it works today, guys. That's not what we do. We have a rigorous training program. We have a rigorous testing regime, and we take it very seriously. One of the things that we take very seriously is understanding who's in charge. And so I'll talk to you a little bit about how our in-car user interface works, so you guys can understand a little bit about how not to confuse the user as, is the car driving or am I driving? Because if the car thinks that you're driving and you think that the car's driving, that's not a good situation to be in. The other way around, it could be bad too, but that's more of a backseat driver problem. So right now, as the car boots up, it's driving around. The car's in manual, and you kind of get a regular screen that just shows you you're going at 32 miles an hour, whatever. As you're driving on the highway, you get into a lane that works. This little screen pops up, and you have effectively shows you which lanes you can drive, how long you can drive. So if you're in lane 2, like you're shown here, you could go 3 miles. If you're one lane over, you could go 28 miles. So you might want to move over one lane so you can kind of cruise for 30 miles. Then you press the button, and then at this point you get an audio chime, and the vehicle starts to drive for you, and you feel it, the steering wheel, so you can kind of let go, and you see a richer graphic that's showing you a road ahead, so you can understand what's happening and be comfortable that the vehicle is driving down the right highway. Then as you're reaching your destination, several minutes later, the car will kind of warn you ahead of time and say, hey, you got 30 seconds before we're going to need you to start driving. So it's kind of like a wake-up call. And then you have another 10 seconds later, you have another bit of warning that says like, hey, please turn off the system. Then 10 seconds later, you have another warning that says turn off the system. And then if for some reason you've had a heart attack, or had a coma or something like that from these multiple physical and auditory and visual warnings, the system will have a final really big warning for you, and then at that point, if you don't take over, the vehicle will safely come to a stop, which we think is important. You can't just say, hey, I need you to drive right now, and then hand over the controls. So that's kind of our overall UI flow. I'll tell you a little bit about a couple things. So Jim's here, so I thought I'd give some of their VPs great quotes. For some drivers today, the distraction is not texting, it's the driving that's the distraction. And if you think about that, that leads a little bit to why this technology is going to be so important, is because you can't fix human nature. You can prohibit it, you can put all these rules in place, but fundamentally the desire is there. Fundamentally the desire is not for people to drive. They want to be doing something else. Transportation is important, but driving, not so much. For me, this is I have about an hour on a good day, some days 2 to 2 hours work commute, and I can do about 45 minutes of that automatically, which is pretty fantastic. In California, 2 cars exactly the same, 2,000 Priuses, 50,000 miles, 52 miles each. 16,000 and 22,000. What was the difference a couple years ago? This car had a carpool sticker that allows you to drive in the HOV lane and go faster. So that sticker was worth 6,000 miles. That's the value of time for somebody. GM has done a great job at promoting their cars this way. I think it's a fantastic way to think of new technology and getting people excited about it. Basically, it boils down to about having $55 an hour for these people that are paying these stickers for. Last thing I'd say is, here's another ad by Volvo. I think there's no encouragement needing to help people come up with ideas on what they're going to do with all the time that they get back. I I think we need to focus on making the technology work, making it safe. People are creative on their own. This is a picture from DC a couple weeks ago of a person literally taping a cell phone to their wheel. I don't recommend it. You might have a cell phone in the face if you have an accident. Here's another example of some crazy stuff. Highway 880, playing trumpets. We took this out of our car driving one day, and my favorite is a way to eat lunch in the car. And so I would say, let's keep the facts in mind. So this is all fun to be like funny, but there's some serious things. Many people die each year. This is the #1 cause of death for 3 to 33-year-olds in the U.S. And the shocking figure here, to me, is that 3,331 people in 2011 died because they were distracted. Can you just imagine that? It's not that you're a bad driver. It's not that your car broke down. It's not that you were being reckless or doing anything else. You were just distracted. That's just unacceptable to let the fact that you can be distracted kill you. That's one of the things that's shocking to me. Same thing for drowsy drivers. Imagine you're driving home. You just want to get home so you can get in your bed, and then you fell asleep, and you died. That's also something that's unacceptable. So these are easy classes of problems that we can address with this technology. Another easy one is 5.5 million hours lost every year. There's a huge aging population. I think they're going to all love having this technology in order to be able to keep driving cars. And this is a picture of a lady who just passed her driving tests at the age of 75. It's not her first time, but it was one that she had to pass in order to keep her license. And she was so excited to be able to keep her license because that meant she could stay in her home. So for a 16-year-old, the excitement to be able to leave the home is exciting. For our parents and hopefully us in the near future, it'd be exciting to be able to rely on technology to just be able to get transportation even past our aging bodies of being able to see or drive the car safely. How do we know that we're safe? Google's got a motto, don't be evil, organize the world's information. But the engineering inside Google has another one, which is called In God We Trust, All Others Bring Data. And so one of the metrics that we're tracking in terms of having a lot of them is time to collision. How good is that car driving? It's not okay for us to see how many times we've had a fatality, a collision. We need to see how many times we have near misses. And we have a bunch of these different metrics. But one of the metrics that's really important to us is time to collision, which is how many seconds before collision are you driving, and how do we do on that? Compared to humans, think of it as like whenever you're driving within 2 seconds of an accident, meaning that if you were texting for that period of time, you would have gotten in a collision. You spend about 0.5% of your driving there for humans, and the system currently we have spends about 1/5 as much of that. So we're kind of 5 times safer on that metric. So the last thing I'll say here is 100% effective. No, the technology is not going to be 100% effective, but will it improve the way we have safety today? And I think that it can. If we look at like other metrics, things that we take for granted as absolutely improving safety, turn out to be so-so. Seatbelts are roughly 50% effective in passenger cars or light trucks. Child seats are 71-50% effective, which is fantastic. But frontal airbags are only 14% effective. Electronic stability control is only 50% effective. So, let's figure out how to get the 95% of collisions under control. So with that, I'm happy to take questions, or we can move on.